Hello friends! Let's start by adding a variable to keep track of the player's currency in their save file, which in this project is the progress resource. Exporting the variable so it will be serialized and saved, let's call it coins. It will be an integer with a default value of 0. Next, let's display this information on the canvas using a label node. After setting the font and font size, it's a good idea to decide on a limit of how large a number you want to allow to be displayed, experimenting with a placeholder number. I'll assume a limit of 10 million. It would be nice to have an icon beside this number to tell the player what it means, so using a textDirect node, populated with a coin icon, we can put both as children of a horizontal box container to arrange them for us. Let's rename the parent node Wallet. And move it to be behind the fade. I think the coin counter will look best in the upper left corner, which it is already anchored to, but with 32 pixels of padding from the edge of the window. The icon is too large, so I'll change its stretch mode to keep aspect to maintain its aspect ratio, and have it automatically resized to fit its width proportional to its height. Resetting the height of the parent container, it will now be set by the label node's font size, which is apparently 42 pixels. The height of the icon will also be 42 pixels, and thus with a 1:1 aspect ratio, the icon will also have its width set to 42. I'll also have the text centered vertically and add a 16-point black outline to the number to match the outline around the icon. Thinking ahead, I would like to have the icon pulse slightly when the number changes. Setting its custom minimum size Y value to 42, click and drag it to the right, and we can see the effects of increasing and then decreasing this value over time. Doing this rapidly, we can see the effect of applying a quick but subtle pulse effect, which will also slightly move the text label, grabbing the player's attention. I would also like to keep the canvas clear of irrelevant information while the player is playing the game, so I'll have the money counter hidden when it isn't needed. Selecting the wallet node, we can click and drag the position Y value to see how it can move up off the screen to hide and back down again to show itself. Let's start the wallet in its closed position, where its position Y value will be the same as its size Y value but negative. After displaying the wallet, we can start a timer to automatically hide it after a duration of time using a timer node. Let's name it AutoHide, and set its one-shot property to true so it will only count down once when requested. To keep the demonstration short, I'll auto-hide the wallet after just 3 seconds. Adding a script to this node, let's call it counter, and save it in the UI scripts folder. It can inherit from control since it doesn't need any behaviors of the horizontal box container. We'll need references to all of the child nodes set during the ready phase, and a private tween variable. Public functions will be available to tell this node to open or close, returning the tween finished signal when done, and one to set the value of the counter. Opening the counter will be accomplished by tweening its Y position to positive 32, and closing it will do the same to the negative of its size.y. It would be a good idea to export these as variables to make the script more reusable for other counters. Adding on-screen position and off-screen position variables, both as vector2. Open can now tween the node's position to be on-screen, and close tweens to off-screen, changing the float argument into a vector2. Tweening the node's position, accepting a new position as a vector2 parameter, and returning the tween finished signal. We'll first check if a tween exists and is running. If so, kill it, and create a new one. We can then tween the node's position to reach the new position over a duration of time. Let's export this as another variable and give it a default value of 1 second. Remember to set the values of the on-screen and off-screen positions of this control node in the inspector. To set the value, we need a new value to set it to, which should be an integer. We will be setting the text property of the label node to match this integer after casting its type to a string, but clamping it to be between 0 and the maximum value allowed by our display. But first we should check if the counter is currently being displayed, and if not, await the open function. For that, we will need a Boolean variable telling us whether or not the counter is currently open, which will be set to true during the open function, but only after the tween has finished. Then also await the icon pulse animation before updating the actual number. Or you can omit the await here to have the pulse and the number update simultaneously. Adding a pulse function returning the tween finished signal. After doing the usual tween checks, I'll simply tween the icon's custom minimum Y property to be slightly larger, let's say 46 pixels, over a duration of 1/10 of a second, then tween back to its original size over the same duration. We can also export variables for the duration and size of the pulse if we want to. Note that because of the node settings I'm using, shrinking the icon to be any smaller than 42 pixels will be ignored. You can always change the type of the horizontal box to be a normal control node and manually position its children if you want more flexibility. Selecting the auto hide timer node, we can connect its timeout signal to the counter's close function by selecting it from the list. The green arrow shows the function is connected to a signal. Sometimes we may want to disable the auto hide feature, so let's add that functionality with an optional Boolean parameter called stayOpen, defaulting to true. Storing this in a local variable of the same name, we can use this as a condition before requesting the auto hide timer to start, disabling the auto hide behavior and keeping this counter open. When setting the value of the counter, if the counter is not already open, then it stands to reason that the counter has not been told to stay open, so we should await its opening and pass false as the argument to trigger the auto hide, and set isOpen back to false when closing. Now let's switch to the level scene and create a stack of coins that the player can pick up. Starting with an Area 3D node, let's call it CoinStackSmall. Then drag the model asset onto the Area 3D node to add it as a child. Right-clicking on the coin stack, select Make Local to separate this node from the imported asset, making it just a local copy instead of a reference to the asset. Now we can extract just the Mesh Instance 3D node that is drawing the coin stack and remove everything else. Make sure the coins are resting cleanly on the floor, adjusting your perspective if necessary. Next, we'll add a collision shape for the Area 3D node. I'll use a sphere, give it a radius that surrounds it sufficiently, and move it up above the ground. Let's attach a new script to this coin stack, called CoinStack. I'll put it in the Event Scripts folder. And have it inherit from Proximity event to automatically react to collisions with the player. For more information on events, see the Dialogue and Events course in this series. Let's export a variable for the amount of coins that are in this stack as an integer with a default value of 10. We can also restrict this value to be contained within a range using the export range tag, specifying a minimum and maximum value allowed for this variable. A stack of coins should not be empty, so the minimum value would be 1, and I'll just put the maximum at 10 million. Providing a definition for the event manager to call this script's run event function, accepting the event manager as a parameter, We won't need to use it, so it can be preceded with an underscore. We need to set the progress variable to be plus the value of this stack of coins, then destroy it using queue_free. We'll also need to override the onBodyEntered function to tell the game manager not to disable the player node during this event. Let's make this stack of coins its own scene, saving it in the scenes folder, and create a new subfolder for items. Then move the stack away from the player's starting position. The last thing we need to do is update the UI when the coins are collected. There's probably going to be a lot of coins in the game, and we don't want to manage their signals manually. That would be a waste of time. An easy way to accomplish this is to use autoloaded signals. Creating a new autoload script, let's call it global, and give it a signal called coinsUpdated with an integer parameter for the new coins amount. This script is also useful for providing values for commonly used variables across different scripts throughout your project, particularly ones that are not meant to be adjustable by the player in the game settings. We can then add the global script to the list of autoloaded nodes in the project settings. The counter script attached to our wallet can now use the ready function to connect this signal to its setValue function. Setting the label on the UI to match the argument passed through the signal emitted by the global autoload. And also initialize the value to whatever is stored in the player's save file when the game first loads. But this is no longer a repurposable script. So let's give it a class name counter. Then create a new script inheriting from counter called wallet. Which will have this ready function directly tying it to the player's coins. Replacing the script attached to the wallet by dragging it onto the node. The counter script can now be used to count anything displayed on the UI, such as keys or health potions, for example. In the progress script, adding a setter function to the coins variable, we can tell this signal to emit automatically anytime the value changes. Using an if statement, we can make sure the number isn't being set to what it already was. Let's try it out. Walking over to the coins, they disappear, the wallet appears with a balance of 0, which pulses and updates to be 10. Then after a 3-second wait time, the wallet hides itself. We now have coins that the player can pick up and keep track of on the game's canvas. In the next lesson, we'll add visual and audio effects to improve the look and feel of these game mechanics. I'll see you in the next lesson.